Hi everybody, Chris Biddle from Light 23 here. So what I have here is the EL1601 nightlight that I've designed and built. And I did do a previous video of how I built one of these displays, but this is kind of a more enhanced or improved version that actually includes a component that lets you Wi-Fi connect to it and control the control the display from a web page on your smartphone. Um, in the video, I'm going to go through some fairly extensive detail on how I assembled it, all the wiring and everything. I hope you can get a lot out of what I'm about to show. Okay, so here is the 3D printed base, the very bottom part of the light display. And I printed it using PLA at 20% infill density. These 4 holes here are going to take the NodeMCU, and then these 4 are for the Arduino Uno. This hole here is just to be able to get your finger in there and grip the base and pull it out of the cover. The cover is this part here. It has 16 slots in there, and they're designed to take 1/16 inch acrylic panels. It has these little nubs, one on this side and 2 on the other side to help hold the acrylic panels in place, and also lets you be able to put the panels in fairly easy. This hole here is for the NodeMCU to be able to plug your USB cable into the NodeMCU here, and this one is for the Arduino Uno. And then this hole here is for the power, and for the power barrel jack, and then this one is for the switch. Then what you're going to do, what's going to happen is you're going to take one of these, actually 2 of these LED matrices, and slip them in with the LEDs facing toward the grooves, and another one in here. And then these are going to be joined together, so the 2 panels will basically be chained together and operate as one. So on to the next step. So I put some double-faced tape in here in between the slots in order to hold the LED matrices. That way when I put the matrices in there, they're not going to try to pull away from the slots. So what I used is this double-faced Sure tape. It's kind of like duct tape, and it has some pretty good tack to it. So I just wanted to point that out before I actually put the lights in there. Okay, so I've got the LED matrices in there with the LEDs themselves facing outward through the grooves. And I've gone ahead and removed the extra wires that we don't need. I just snipped them off and then just taped off the terminals. I used to leave them in there, but there's really no need. I don't intend to reuse the matrices. So I've just snipped them away because they're kind of distracting. So the 5-volt power is going to be fed through the red wire, and then the white wire is the ground, and then the green is the data in. So the data in is going to come from the Arduino, pin number 7. And then you have the data out going to the data in on this matrix, and also the power and the ground are connected together. So all the power for both matrices are going to be fed through this one wire. So as the next step, what I'm going to do is take one of these barrel jacks and connect it up to the base cover this way, and it has this little washer that gets attached to it, as well as a little nut. So I'm gonna be attaching this to the base. I also have a little single pole, single throw switch that goes in this groove here, and it just kind of fits in there snug like that. And then we're going to be attaching the hot wire to the switch, so connecting it up to this terminal here, and then coming out from this terminal here. And then, so that's going to be the basic voltage power supply. And then the power is going to fork off so that it's going to be powering up the hot wire here to the LEDs, but it's also going to have to fork off and power the Arduino. So I'm going to be building that circuitry for the power, and then the ground is going to be the same arrangement where the ground is going to fork off to the Arduino as well as to the white wire here. So that's the next step. So I'll get you a video of that once it's complete. A real critical component of this light display is this 220 ohm resistor that needs to be in line for the data line that's running from the pin number 7 on the Arduino and feeding into the LED. Just want to make sure that you do solder in a 220 ohm resistor to limit the current that's going into the data line. That's really important, and that's pretty common with most LED installations where you're driving WS2812Bs or 2813s. A lot of these NeoPixels, they want a resistor in the data line. So I just soldered one in line here, and then I'm going to be wrapping it up in a couple layers of shrink wrap. So I just wanted to point that out before we continue. All right, so I've got the majority of the wiring put together here, so let me just kind of walk you through what I did. So starting with the 5-volt voltage supply, which is going to be coming from this barrel jack, I'm connecting the hot wire to the single pole, single throw switch here, and then from the output on that switch, I am going to this little three-way junction that I've just kind of tied together. So from the switch, I'm going to that junction, and then from that junction, I have a 5-volt lead that's going to plug into the VIN on the Arduino. And then the other wire coming out of that three-way junction is going to be going to the LED. So I've got this this connector here, and you can see how it's all just follow the red wire, and it goes to the 5-volt voltage in on the matrix. And then the ground is the same, very similar arrangement where I'm coming from the barrel jack, and I'm leading to this three-way terminal or junction here, and I'm going one of the leads coming out is going to the Arduino Uno, the ground on there, and then the other lead here, this white lead, is the ground that's going to go to the LED matrix. So ground going to the Arduino and ground going to the LED matrix, all through this ground connection on the barrel jack. Very similarly with the voltage supply. Finally, we have the data line. So the data line runs from, it's going to connect to pin 7 on the Arduino. And as I showed you earlier in the video, we've got the little resistor in place here, and I've shrink wrapped it really well. So that's a 220 ohm resistor going from the Arduino and going into the data in on the LED. So this data in, just follow through with the green wiring, and you'll see that it'll go to the data in on the LED matrix. So those are the three wiring components that I've got put together so far. So there's a couple more steps. Obviously, we have to hook these up to the Arduino now, so that's the next step. And we also have to connect the NodeMCU to the Arduino, both in terms of the voltage and data. So I'll be showing you that in the subsequent few minutes on this video. All right, so that's what I've gotten done so far. On to the next step. So for my next step, we're going to be attaching the Arduino Uno to the bottom base here using these 4 holes. So they'll be attaching, it'll be attaching that way. And then the NodeMCU is going to attach upside down to these 4 holes. And we just want to pay attention to where the uh, pins are, the location of the voltage and ground and so forth. So voltage in, the VIN is this pin here, and then ground is this one here. And then over here, we've got the data pins, D0, D1, and D2. We're going to be using D1 and D2 to connect to the Arduino's A4 and A5 pins here. So that's going to be the I2C communication going on between them. So if I flip it over, so this one's the D1, this one's the D2, and then we got the VIN and the ground. So let me go ahead and attach those. I have a bunch of assorted small screws that I'm going to use, and then I'll get the wiring connected and we'll go from there. Okay, so here it is connected up. I've got the Arduino Uno and the NodeMCU attached to the bottom baseboard, and then I've got the D1 and D2 pins connected to the A4 and A5 pins on the Arduino. So like I said earlier, this is going to be the I2C communication. And then the NodeMCU is going to be powered up from the Arduino. And it's going to be powered up from the 5-volt output on the Arduino into the VIN on the NodeMCU, and the ground would also be connected together. So that's how the NodeMCU is going to be supplied with the power. So those are the only 4 connections between the NodeMCU and the Arduino. All right, so the next step is to attach the wiring from the from the cover that we had assembled earlier. And once we do that, the Arduino will have the power it needs, and then convey that power to the NodeMCU. And then this green wire is going to go into pin 7 on the Arduino for the data to drive the LEDs. So let me do that next, and then we'll test it out. Okay, so I have the final 3 connections made to complete the circuitry. What I did was I took the voltage supply coming from the cover here that we assembled earlier, that's running from the barrel jack to the switch to this little junction here. That extra voltage supply pin is connected to the VIN on the Arduino Uno right here. And then the extra ground pin that I had coming from this little junction that's connected to the barrel jack, that is going to the ground on the Arduino right here. And then we have the green data line to drive the LEDs. That pin is connected to pin number 7 on the Arduino. So the data for driving the LEDs is going to be coming from the Arduino code through pin 7. So those are the 3 additional connections I made, and that pretty much completes the circuitry here. So now it's a matter of uploading the code to these 2 devices, and then powering it up and testing it. Okay, so I got the code uploaded into the 2 microcontroller components, and I've powered it up, and we can see it's all working very nicely. So now it's just a matter of closing it up and putting the acrylic panels into the slots, and we'll be done. So to close this up, what we want to do is we want to orient the cover so that the hole where the USB cable is going to be able to access the Arduino, that hole is over on this side, on the same side as where the Arduino is. And also that way the NodeMCU will line up with the hole where you can access the USB input on the NodeMCU, like that. All right, so we're just going to sort of nudge these cables, squish them down a little bit, real gently. And there is room for everything in there. You'll probably feel a little resistance as you put the wires, as the wires push back a little bit, but basically there won't be too much pressure on the wires. There's plenty of space there, so we just want to close up the bottom cover there, and then take these number 4 screws and just screw them in. And plug the power back in there and power it back up. And there we go. So the final step is just to put the panels in, the acrylic panels. So I'm taking these acrylic panels one at a time, and as I slide them in place, I basically slide them in from the side and kind of work them in across the slots instead of just coming in from the top. In other words, instead of just coming in and putting them in from the top, I kind of slide them in from the side. And the reason for that is because this has been 3D printed. So the ridges on the, you know how a 3D printed product is, it's printed in layers. So if you try to just push them in from the top, it sort of pushes against those layers, and you'll feel kind of like a crunching and some resistance. I mean, you can do it, but they seem to work themselves in a little easier when you just slide them in from the side. Okay, so here's the display completed with all the acrylic panels put in, and I've just powered it up, and it's just by default going to cycle through the 5 different animation patterns that I have in there. So it's a pretty mesmerizing effect. Now, you can also connect to it because I have the NodeMCU programmed in there. You can Wi-Fi connect to it from your cell phone, and there's a web interface that you can pull up that lets you select specific animation patterns and just have it hold on there. And also on that interface, you can change the brightness. I have 3 different brightness levels on there, so I'll show that shortly. All right, so now I'm going to show you how you can connect to the display from your smartphone using the Wi-Fi connection that's being served up from the display itself. As we've seen in the assembly, there's a NodeMCU component, and that's acting as the web server that can serve up a web page that lets you connect and control the display from your phone. So I'm going to go in, I have an Android phone here. I'm going to go into my Wi-Fi settings. So settings, and then connections, and then Wi-Fi. And then in there, you'll see an available connection called EL1601 Nightlight. So I'm going to connect to that. And when I connect, I've already previously connected and entered the credentials, the password. So it's not going to prompt me for the password again. But the first time you connect, you will be prompted for a password, and that password is actually available in the code that you'll be downloading. So if you download the code from the link I'll be providing along with this video, you'll see in the comments exactly what the password is, and you can connect to it. That way you'll have to enter that password. Anyway, I'm connected now. It says connected without internet, so your internet won't be available on your phone temporarily while you're controlling the nightlight. Anyway, once you connect, then you'll want to open up your browser and go into the http://192.168.4.1. That's the IP address. 192.168.4.1. So once you enter that IP address with an HTTP connection, you'll see this little interface that comes up that lets you control the display. So you can choose to cycle all patterns, which is what it's doing by default, or you can do this one at a time movement where it's just scrolling a single panel at a time. This is the shuffle back and forth where the pattern is going back and forth. You have this multi-panel, what I call a multi-panel train selection. So it's kind of like a train of panels going by. And then there's one I call fading trails, where it's just sort of you have this sort of gradient effect where the panels kind of gradually fade as they move. And then of course everybody likes the rainbow. It's kind of hard to see the rainbow rendering there because it's kind of bright, but anyway, you have the rainbow pattern that you can choose as well, and then you can also go back to cycle all patterns, and now it'll just cycle through all these 5 other patterns. You can also adjust the brightness, so I think by default it might be at medium, but you can choose well, say the low brightness, and that might be good for when you're trying to sleep. And then you can increase the brightness to medium or high, and medium, low. And then this is just kind of like a little standby option where you can turn it off temporarily. In this case, there's actually power going to it, and but it's just kind of in an idle mode, and then you can turn it back on, and there you go. So that's a real simple interface that lets you control the nightlight. Now, in the code, you'll see the HTTP code that gets served up, and also basically just have to kind of follow through the programming. And as you learn the code that's in there, look at the source code and study it, you'll be able to just modify this however you like. So the code that I've provided that gets uploaded into this display, just consider it starter code, and you can you know, this is all open source, so you can change this however you like. So anyway, that's the feature that lets you control the display from your smartphone. Again, I have an Android here, but I'm sure it works just the same on an iPhone. There has to be a way you can Wi-Fi connect and pull up a web page, and you should see the exact same thing. All right, so that's all I have for showing how this display works on the smartphone. Thanks for watching.